Hello viewers. Today we will be solving the IB Math EAHL November 2024 paper 2 question number 10. You will be getting the solutions for the first 9 questions of this paper and the other solved questions from the other past papers in form of playlist on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Senyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So, without any further delay, let us start answering this question. The maximum mark is 15. It says the following table shows the population of Canada T years after 2000, after the year 2000. T years after 2000, you are having 0 years after 2000, 5 years, 10 years, 15 years, and 20 years after 2000. And P is the population in millions, 30.7, and these are the 5 values given. And a student uses linear regression to model the population of Canada using these data. The student model is given by this regression equation P equal to AT plus B. Subpart A's question, it is having two further subparts. The I says write down the value of A and the value of B. Okay, so let us use the calculator. We have to go to the spreadsheet. So it is this. And you can name these two columns if you want. It is better to name because as later on when we go to stat calculations, it may be difficult, slightly difficult. And the other one will be P. Fine. So it is 0, 5, 10, 15, and 20. Okay. And this is 30.7 and 32.2, 34, and then 35.7, and finally 37.9. Okay. Fine. Let us come to menu and then statistics and then stat calculations, and then we need the linear regression. So we will be opting for this mx plus b. You are seeing it is e equal to et plus b. So we will be opting for this one mx plus b. And x list over here we can see you are having p and t. So if you name the two columns, it becomes easier. So it is t for the x list, the independent variable, and this one, it is the P, and then it is this. Okay. So linear regression, it will be mx plus b. So m is a, m's value will be the a's value, and b is the b. Okay. So a is equal to 0.358. A equal to 0.358, and b is equal to 30.52. Correct to 3 significant figures, it is 30.5. Okay. Correct to 3 significant figures. I interpret in context the value of P, that is 0.358. Okay, so starting is 0. Okay, so what will be the population at when T equal to 0? It is P equal to A times 0 is 0. So it will be just the B value, it will be 30.5 millions. Okay, now they have come straight to 5 years. So I'm writing t equal to 5. So what will be the corresponding population? It will be 30.5 will be there. Plus b is there every time. Since it is after 5 years, what is happening is it is getting multiplied with a. So it is 0.358 times 5 plus 30.5. So you may assume it may happen that the population hasn't increased in the same rate at the same rate, but over here there's no scope or possibility of determining what is the rate of growth in each year. We will be assuming that the rate of growth per year is the same. So this is times by 5 because the we are having counting the population after 5 years. So after 1 year, what would the population be? It would have been p equal to 0.358 times 1 plus 30.5. After 2 years, it should have been 0.358 times 2 plus 30.5. So what is the difference? First time it was just 30.5. After 1 year, it is 0.358 million is getting added. After 2 years, again another 0.358 is getting added because 0.358 is getting multiplied with 2. So you are seeing that after every year, every single year, this 0.358 million is getting added to the population. Okay, so this is the interpretation of the value of A. So we can write the value of A gives the increase or average increase you can write, because in reality it may had happened that 1 year on 1 year the growth had been more, slightly more, another year the growth had been slightly less. On an average growth of population in millions. That means the population increases by 0.358 millions every year. Okay, this is the average growth of population per year in millions. Okay, it is increasing at the rate of 0.358 million every year. The student uses this model to predict the population of Canada in the year 2030, where t is equal to 30, and calculates a population of approximately 41.3 million people. Subpart B, comment on the reliability of students' prediction carrying 1 mark. So you see, this is giving the t value up to 20 and the prediction is done for t value equal to 30. So it is the case of extrapolation, so the reliability cannot be stated. It is not at all reliable. Okay. So it is B. Since 30 is greater than 20, this is a case of extrapolation. Therefore, not reliable. Okay. A data scientist, Benoit, I'm sorry if I'm not reading this name correctly, uses additional information to develop an exponential model for Canada's future population. In this model, B of t is equal to 33.5 times 1.005 whole raised to the power of t represents the millions of people in Canada t years after the year 2000, where t is greater than or equal to 25 but is less than or equal to 100. Support C is again having two further supports. IS used Benoit's model to predict the population of Canada in the year 2100. So the T's value is 100, okay? Because it is 100 years after 2000. Okay, so let us solve this support C rather over here. And it will be, T will be equal to 100 for 2100. Should be equal to 33.5 times 1.005 raised to the power of 100 is equal to, okay, 33.5 times 1.005 raised to the power of 100. Enter. 55.16, and also correct to three significant figures, it will be 55.2. Okay. 55.2 millions correct to three significant figures. Okay. Support II, interpret in context the value of 1.005 in Benoit's model. It is, okay, we are seeing that 1.005, if we take t value, the smallest t value is 25. So let us take B 25. This should be equal to 33.5 times 1.005 raised to the power of 25. Okay. And if we take B 26, means the t value is 26, just the next year, what will be the population? All these are in millions. So it will be 33.5 times 1.005 to the power of 26. So obviously this one will be more than this, because the base is the same, the power is changing, power is more, 26 is more than 25, the coefficient is the same, so B of 26 should be more than B of 25. So since B of 26 is greater than B of 25, the population is growing. Or you can write the general case. B of t plus 1 is greater than B of t, therefore the population is growing. Is growing. Now let us find the growth then, because this one is a general sentence I have written. This has no connection with It has some connection, but I did not show the connection of this statement with 1.005. I have to establish that. So what will be the growth? Let us see the growth in percentage. So therefore, the growth percent will be equal to, say, b of t plus 1 minus b of t over b of t times by 100, because I'm trying to get in percentage the growth in percentage, so I have to multiply with 100, and this is the difference in population and divided by the original population, the population of the previous year. So this is the same general formula that we use. So b of t plus 1, what is that equal to? It is 33.5 times 1.005 raised to the power of t plus 1 minus 33.5 times 1.005 raised to the power of t divided by 33.5 times 1.005 raised to the power of t times by 100. Okay. And let me take out the common factor as 33.5 and 1.005 raised to the power of t. Okay. So from this first term, we will be having, this can be written as 1.005 raised to the power of t times 1.005. So this is 1.005 is coming within the brackets, and from this second term, it will be just 1. Okay. Over 33.5 times 1.005 raised to the power of t times 100. So these two will be getting cancelled, and 1.005 minus 1 is equal to 0.005 times 100, which is equal to 0.5%. Okay. So the factor of 1.005 suggests a growth of 0.5% every year. Okay, fine. Another data scientist, Cecilia, develops a third model for the Canadian population. In this model, C of t equal to 62 over 1 plus e to the power of negative 0.02 times t represents the millions of population in Canada. T years after the year 2000, t is between 25 and 100, both included. Subpart D's question is, use Cecilia's model to predict the population of Canada in the year 2100. So the t's value will be 100. Okay. So D, C of 100 is equal to, calculator, division 62 over 1 plus e to the power of negative 0.02 times 100. Okay. $54.6 millions. Okay. So 54.6 million. Correct to three significant figures. Subpart E. Determine the year in which the difference between the predictions from Benoit's model and Cecilia's model is greatest. We do not know whether this model will be having the larger value or this one. So better to take the absolute value notation between these two models. Okay. So we have to graph the B of t minus C of t between 25 and 100. Okay. And we have to see when is the difference greatest. So B of t was what? Okay, it was this one. First of all, we need the absolute value, T3.5 times 1.005, sorry, raised to the power of x minus Cecilia's model is this one, 62 over 1 plus e to the power of negative 0.02 times x. Okay, and I come out of the absolute value notation and let us graph this. It should be between t equal to 25 to 100. So let me just go to the Windows settings. It will be, let me take 24 as the x min and x max as 101. Okay, let's see. So this is the maximum value. So I have to use the analyze graph and maximum. It is 58.6. Okay, is maximum when t is equal to 58.6. Therefore, year is, it will be 2058 and some months. So let us take 2058. Okay. Subpart F. Find the value of, it is also containing two further subparts. So b dash 75 and c dash means first derivative of b and t's value is 75. Same for the c. So it is F. And again, I have to go back to see the expressions. Okay. So I come over here and I need the derivative. It is with respect to t and it is 33.5 times 1.005 raised to the power of 75 or t rather. I cannot write 75 over here because then it will be a constant. Okay. So, and then I have to use this pipe symbol, the vertical line. And now I have to give the t value. So, t is equal to 75. Enter. 0.242876. So, correct to three significant figures, it will be 0.243. Okay. B dash 75 is equal to 0.243, and first derivative of B when t equal to 75 is 0.243. And what about this one? Calculator. Oh, sorry, what is the expression? Yeah, again derivative t, and this one is 62 over 1 plus e to the power of negative 0.02 times t. Okay, and I come out the pipe, and t should be equal to 75. Enter. 0.1849. So correct to three significant figures, it will be 0.185. Okay. Fine. Last subpart. Subpart G. Compare and interpret in context the values of B prime 75 and C prime 75. Okay, so the first derivative will be giving you the rate of growth. So, since B prime 75 is greater than C prime 75, therefore, the rate of growth of the Canadian population is predicted to be more than more using the Benard's model. Rate of growth of the Canadian population is predicted to be more using the Benard's model than using the Cecilia's model. When t is equal to 75. Okay. Using the Benard's model, we are seeing that the rate of growth is 0.243, and using the Cecilia's model, it is 0.185. So it is predicted to be more using the Benard's model. Okay. So we have completed answering this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. It will be really helping me a lot. We meet again very soon when we will be solving the question number 11 of the same paper. Till then, bye.